Have you ever wondered what it might be like inside a star that's twice as massive as the Sun, but only the size of a city? Thanks to observations from a NASA telescope, astronomers are now closer to understanding one of the hardest to reach places in the universe, the inner core of a star on the verge of becoming a black hole. These are neutron stars, a black hole's smaller cousin and the leftovers of an exploded massive star. These objects seem to defy the laws of physics. They pack more mass than the Sun into something the size of a city, producing some of the most intense conditions known to exist. And, unlike black holes, we can actually see them. These cosmic monsters are some of the most extreme objects known in the universe. Scientists recently studied the most massive neutron star discovered, which has more than twice the Sun's mass but is only about 16 miles across. That's not much bigger than Manhattan Island. Scientists are unsure how matter, the material that makes up everything we can see and touch, behaves in neutron stars' mysterious interiors, which are home to conditions we can't recreate on Earth. Thanks to NASA's NICA telescope, which collects data from its perch on the International Space Station, scientists are now a step closer to understanding these strange objects, which could harbor clues to how our universe works. For the first time, astrophysicists have evidence of not just one, but two black holes obliterating highly dense, incredibly massive neutron stars. First detected in January 2020, the intense gravitational waves produced by these events took roughly 1 billion years to reach Earth. The new study is the result of collaboration among more than 1,000 scientists in the field, and its findings could unlock the origins of gravitational waves and some underlying mysteries of the universe. Both neutron stars and black holes are the results of violent star death. When stars die, depending on their size, they lose mass and become more dense until they collapse in a supernova explosion. Some turn into endless black holes that devour anything around them, while others leave behind a neutron star, which is a dense remnant of a star too small to turn into a black hole. Neutron stars' measure can be as small as 20 miles wide, but they are so dense that a tiny teaspoon-sized scoop would weigh as much as Mount Everest. At times, neutron stars are born as a pair in binary star systems when one celestial object orbits another. Previously, binary pairs were only observed as two neutron stars or two black holes. Over a century ago, Albert Einstein first predicted the existence of gravitational waves, which are ripples in spacetime that occur when the most massive objects in the universe collide. Gravitational waves were first detected in September 2015 by the US Laser Interferometer Gravitational Wave Observatory when two black holes collided. Scientists have recorded neutron stars colliding with each other and black holes crashing together, but they had never collected evidence of a black hole consuming a neutron star. They suspected it was possible, but they did not have much evidence until gravitational wave detectors called interferometers provided solid evidence. Interferometers are 2-mile-long, L-shaped pipes that shoot lasers. When gravitational waves pass through the detectors, they interrupt the laser's path. The detectors are hypersensitive, catching interruptions a fraction of the width of a subatomic particle. The first of the collisions between the neutron stars and black holes, dubbed GW200105, was detected on January 5, 2020 by LIGO. Data collected from LIGO revealed that a neutron star twice as massive as the Sun was swallowed up by a black hole 9 times the size of the Sun. The waves, traveling the speed of light, took 900 million years to reach Earth. The second collision, named GW200115, involved a neutron star 50% more massive than the Sun and a black hole 6 times more massive than the Sun. GW200115 was detected by both LIGO and Virgo, an interferometer in Italy. Researchers suspect violent neutron star black hole collisions occur at least once a month within a billion light-year radius of Earth. With upgrades to LIGO and Virgo, more of these collisions are likely to be detected. Researchers hope to witness a neutron star get shredded into fragments of light as a black hole devours it. For these recently detected collisions, no light was emitted because of the distance and how massive the black holes were compared to the smaller neutron stars. Each collision isn't just the coming together of two massive and dense objects. It's really like Pac-Man, with a black hole swallowing its companion neutron star whole. These are remarkable events, and we have waited a very long time to witness them. So it's incredible to finally capture them. Black holes are astronomical objects that have such strong gravity, not even light can escape. Neutron stars are dead stars that are incredibly dense. A teaspoonful of material from a neutron star is estimated to weigh around 4 billion tons. Both objects are cosmological monsters, but black holes are considerably more massive than neutron stars. For example, over billions of years, stars have produced many of the building blocks from which larger cosmic structures such as planets and galaxies are formed. The production within stars of so-called heavy elements such as iron, carbon and oxygen is related to the proportion of black holes and neutron star pairs in the universe. The force with which stars push out the material inside them when they explode is also related to this proportion of black hole and neutron star pairs. In conclusion, the new finding suggests that stars produce fewer heavy elements and push them out with less force than previously thought, which, in turn, has implications for real-world observations of the universe. No existing theory can perfectly explain what astronomers see in the night sky. But, according to Dr. Raymond, many of the ideas can be tweaked to better fit what we now know. In future, the team hopes to detect neutron star black hole collisions which are also observed by telescopes both in space and on the ground. This will enable scientists to find out more about the super heavy materials neutron stars are made of.